Hello, this is Elizabeth back from the Academic Support Center, just continuing to go through these problems on the Pre-Calc 2 review for the final exam. Number 24 says a central angle of theta has a circle with a radius 16 inches, subtends an arc of 19.6 inches. Find theta in degrees rounded to the nearest second decimal. So, with these word problems, I usually like to draw what it means, right? We have a circle, we have a radius of 16, we have an arc, and this part of the arc is 19.36, and we want to know what this angle here is. Okay, so there's a couple ways we can attack this. The easiest way is we have a formula that says theta is equal to S, which is the length of our arc, divided by our radius. Okay, this is going to be in radians. So if we just do this, we say theta is equal to our arc length is our 19.36, and our radius is 16. And if we do that on our calculator, we get that is equal to 1.21. But this is radians. And so to convert from radians to degrees, we need to do 1.21 times 180 degrees over pi. And when you do that calculation, again, just put that into your calculator, you're going to get that's equal to 69.33 degrees. Okay, that's pretty straightforward. We're following this formula. Okay. Number 25 says find an angle theta such that theta is between 0 and pi over 2, and secant of theta is equal to 1.4736. Round your answer to the nearest second decimal. Okay, so we need to do inverse cosecant. I don't have an inverse cosecant on my calculator, so I'm going to apply my reciprocal identities. So we know that, we know that sine theta is equal to, we know that cosecant theta is equal to 1 over sine theta. And we can rewrite this. We can multiply both sides by sine and divide it by cosecant. So we get sine theta is equal to 1 over cosecant theta. And if we want to find theta, we can then just say theta is equal to the inverse sine of 1 over cosecant theta. And now we have something that we're going to plug into our calculator. This is just sine to the negative 1. Cosecant of theta is 1.473, so 1 over 1.4736. We plug that into our calculator, and we get, theta is equal to 42.74. Okay. When you're using your calculator, please be sure that you are in radians or degrees. There's a mode button on your calculator, and you can switch it back and forth. So if you want to be in degrees, if you're reporting your answer in degrees, make sure that when you do this inverse sign that you are in degrees and then not in radians. Okay. Number 26 says, a pilot of an airplane flying at an altitude of 12,000 feet sights a water tower. The angle of depression of the base of the tower is 25 degrees. What is the length of the line of sight from the plane to the base of the tower? Draw the scenario. Round your answer to the nearest feet. So I like to draw a picture. I have an airplane here. Bear with me, it's not the best airplane, but we have an airplane. Okay, it sees a water tower over here. on the ground. On the ground. Okay. Our elevation of our airplane is 12,000 feet. So it means that it's flying 12,000 feet above the ground. And we want to know what the line of sight from our airplane to the base of this tower is. We want to know this distance. Okay? So the base of the tower was the length of the sight of the plane. Base of the tower, draw the scenario around. Okay, so this angle of depression, that is, we want to draw a like horizontal line here. That's this angle. They say that this was 25 degrees. Okay. So we want to know what x is, and I just completed this triangle over here with the altitude. You can draw any of these triangles actually, but we have a triangle here. This is a right triangle. This is 25. This side here is going to be the same as this side here. So this is going to be 12,000. Okay. So we have an angle and we have a side, and so now we just need to look for the trig function that relates this angle and these two sides. Well, this angle, this is our opposite, and this is our hypotenuse. So we can write that opposite of our hypotenuse is our sine. So sine of 25 degrees is equal to 12,000 over x. Now, I'm going to skip some algebra steps because I assume that you guys can do that, but we're going to multiply both sides by x and then divide by sine of 25, and we're going to get x is equal to 12,000 divided by the sine of 25 degrees. And again, when we plug that into our calculator, we get, this is, oh, sorry, this is equal to 28,394. This was feet. So that line of sight is 28,394 feet. Okay, so we're just using the trig function to correlate the angle and the two sides that we know. Number 26. Again, I like to draw pictures, and I'm just going to draw over here. It says a 16-foot ladder leaning against the side of the house, which is 12 feet up the side of the house. So I'm just going to draw a house. And we have a ladder leaned against it. And again, we have grass here. This is our baseline. Okay. So the ladder is 16 feet. So let's label this. This is 16. 16 feet. It reaches 12 feet up the side of the house. So this side is 12 feet. What angle does the ladder make with the ground? Draw the scenario. So this is our angle that we want to find. Okay. So again, this is 16 and that's 12. So again, the question is what trig function relates this angle and these two sides? Well, this is our opposite and our hypotenuse. So again, it's going to be sine. So we can write a trig equation for this scenario. This is sine of theta is equal to 12 over 16. Okay, so now to find theta, we just have to do the inverse sine. Theta is equal to the inverse sine of 12 over 16. And we plug that into our calculator to get an answer. And again, make sure that however you report it, that you're in the proper mode. I did this in degrees, and this comes out to, when I plug this into my calculator in the degree mode, this just calculates to 48.6 degrees. Okay. So I find drawing the picture helps. I'm very visual, but okay. From a point 100 feet in front of a public library, the angles of elevation to the base of the flagpole and the top of the flagpole are 28 and 40 degrees respectively. The flagpole is mounted on the library's roof. Find the height. So again, over here I drew a picture for myself. We have a library and we have a flagpole on the top of it. Okay. And we're standing a point 100 feet away. Again, we have our grass, our horizon. We're standing over here at a point over here that's 100 feet away, and it says this angle. No, my scale's probably off. They said this angle this angle was 28, and this angle was 40. And we know that this was 100. So we want to know this distance here, right? But that distance can be expressed as a difference between this distance and this distance. Okay? So again, we want the trig function that relates this this angle to these two sides. Well, this is our opposite and our adjacent. So this angle, that trig function is tan. So we can write this equation, tan of 28 is equal to x over 100. Okay? And then we can manipulate this. This becomes x is equal to 100 tan 28. The total distance is going to be tangent of 40. Tan 40 is equal to our total distance. We'll just call it y divided by 100. So again, 100 tan 40 is equal to y. So if we do these calculations, x is equal to 53.17 and y is equal to 83.91. So the height of the flagpole is just 83.91 minus 53.17, and that is equal to 30.74 feet. Okay, so again, we're identifying the two sides. We're drawing our picture. We're identifying the two sides and the angle, and we're looking for the trig function that is represented or relates those two. So if you need help with these questions or any other on the reviews, please feel free to reach out. We're here to help at the Academic Support Center doing online tutoring during the COVID-19 shutdown. And good luck on your finals.